In this presentation today, we will discuss about how to solve a partial differential equation by the method of separation of variables. Let us assume that Z are dependent variable and X and Y are the independent variables, and we are going to assume the solution to be the product of two functions. One will be a function of X alone and the other will be a function of Y alone. Then the solution of partial differential equation will be converted into a solution of ordinary differential equation, and then we separate the variables X on one side and Y on one side, do integration and finish. This is how we solve. I'm going to explain it with an example. So we are going to solve 2x dou z by dou x minus 3y dou z by dou y. It should be dou y equal to 0. So this is the partial differential equation. Let us assume z as x as a function of x and y as a function of y. So what we will do is, now let this be the solution. Now dou z by dou x, let us do partial differentiation of 2 with respect to x alone. So when I differentiate with respect to x, x will become x dash. Y will remain as it is because we treat it as a constant. Same pattern, dou z by dou y, when I differentiate, x will remain as it is. Capital Y will become y dash. Now what we do is we substitute in the place of dou z by dou x, dou z by dou y in terms of these two. So substituting this in one, and then we separate the variables. We'll keep x on the left hand side and y on the right hand side. Now as you do this one, let us equate it to a constant k. So now from the first one, I am able to get x dash by x equal to k divided by 2x. And from the second part and the last one, we are able to get y dash by y equal to k divided by 3y. Now we are going to integrate one by one. So the first one, x dash by x, when I integrate, I am able to get log x, and the other part will be k by 2x we had. So it will be k by 2 into log x, and we add a constant. As we are having log throughout, I am adding log a. Now using the laws of logarithm, this term will become log x to the power k by 2, and combining log a plus log b formula, so it is log of a into b. So it is log of a x to the power k by 2. So from here I am able to get x is equal to a x to the power k by 2. Same pattern, let us do the integration of the next one with respect to y. So log y will be this, and so on simplifying, I get y equal to by power k by 3. So the final solution, u x as x alone, y as y alone function of x and a function of y. So let us substitute for capital X, capital Y, and a and b are constants. So let us combine those two constants as a single constant c. So u equal to c into x to the power k by 2, y to the power k by 3 will be the required general solution of the given partial differential equation. Now in the next one, we have dou u by dou x equal to 2 dou u by dou t plus u, and they have given a condition also, u of x comma 0 is 6 into e power 3x. That is, when t equal to 0, u will be 6 into e power minus 3x. So this is given for us so that we can find the constant also. So let us consider this equation, and we are going to solve this, get u as a function of x and t, where capital X will denote it's a function of x alone and t is a function of t only. So let us come on differentiate partially 2 with respect to x first and then with respect to t. So this will become x dash t, and with respect to t, when I differentiate, it is dou u by dou t equal to x t dash. Now substitute all this in one and rearrange so that we are able to get x on. We are separating the variables, one variable x on one side, another variable t on the other side. That's why this method is known as method of separation of variables. Now we are going to just equate it to these two ratio. We are going to equate it to k. Take the first and the last and second and the last to get x dash by x equal to k. Second and the last will give me t dash by t. The other one will actually become 1. I am taking it to the other side as k minus 1, and this 2 has been brought to the denominator. So this is my x dash by x, which when I integrate will give me log x, and this will be t dash by t, that will give me log y. The other one is, they are only constants, so that when we integrate, this is how you will have. Here it is kx and here it is so much into t plus an integrating constant, combining all log together. Log x minus log a. Log a minus log b is log of a by b. Same procedure here, and then taking anti-log, this is what we have. So x by a equal to e power kx, and here t by b equal to e to the power k minus 1 t by 2. So finally your u will be xt equal to this multiplied by this. Now this is what we call it as the general solution of the partial differential equation. Now for finding the values of the unknown constant, what we use is u of x comma 0 is 6 e power minus 3x, that is when t equal to 0. So in this I will put t equal to 0, so e power 0 is 1, so and u is 6 e power minus 3x, so 6 e power minus 3x will be equal to ab e power kx, or by ab is equal to 6, and in the place of k, when I compare e powers, when I compare it is minus 3. So let us replace wherever I have AB by 6 and K by minus 3 in this solution. So U equal to 6 into e to the power minus 3x, and this I substitute to get minus 2t, which will be the required solution.